So here's a chart in your book, which you may or may not find helpful. Inorganic nomenclature flowchart. So nomenclature, system of naming. Inorganic, these are compounds that are considered not to be organic chemicals. And chemists use the word organic in a very, very different way than they do at the grocery store. So we have three categories: ionic compounds, molecular compounds, and acids. And the key to naming and identifying compounds, to writing their formulas, is you first have to recognize which group are they in. And that way you know which set of rules to use. So ionic compounds, it's going to contain a metal and a nonmetal. The one exception is the ammonium ion. If you see something that starts with NH4, it's going to be ionic. And then here's a summary of the rules here. Just a reminder, we have cations that do not need Roman numerals, cations that do need Roman numerals. The ones that do not are those in groups 1A, 2A, 3A, zinc, and silver. They don't need a Roman numeral because each of those metals forms only one kind of ion. If it's not in that group, it needs a Roman numeral. Molecular compounds is what we talked about today, just nonmetals. And we use the prefixes. And then acids. It's going to start with hydrogen and then have one or more nonmetals. If it's got oxygen, it's an oxyacid. You name it based on the name of the oxyanion. If it isn't, then you use hydro and the suffix ic on the ending of the base name. Yes?
The only thing I don't understand is for the ionic metals and nonmetals, when you trade I for ite or ate, or is that just in the group where it's the...
Okay, so for anions, what's the difference between ite, ate, and ide? That's basically your question?
Yeah.
Okay, that's a good question. Let's see. So ide is used for monatomic anions. So that is just one atom. So just carbon, well, no, not carbon, just oxygen, just phosphorus, just sulfur, just chlorine. So an example would be Cl-, that's chloride. The ite and ate endings are the polyatomic ions. So nitrate, sulfite, SO4, SO3 2 minus, NO3 minus. It's a combination of nitrogen and oxygen or sulfur and oxygen.
Then how do you know whether you put ite or ate?
Well, you have to memorize them.
That's just the memorization part like that?
Just memorized.
Okay.
Yeah, I know it's a bummer, but...
I'm fine with memorization as long as it's not something I'm missing for once.
No, you're not really missing anything. This is really all there is. Now, I got to tell you, there's a couple of exceptions to the ide thing. Hydroxide is OH minus, and cyanide is CN minus, and so they're kind of bucking the trend. But generally, if it ends in ide, it'll be like nitride and 3 minus.
So is an exception to something?
There has to be an exception to everything, yes. It's sad but true. Any other questions?